Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into some log properties, logarithm properties, and their misconceptions to get you guys ready for your next activity here in MRWC and getting you ready for activity 3E2, which is all about how to use log properties, okay? And there are quite a few of them. So we're going to get into the property itself, how it's used, and what's the common misconception that I see over the years. So let's get through some exponents first. In order to be good at logs, you have to be good at exponentials and the powers of either 2, 3, 4, 5, or 6, and sometimes even higher, like powers of 10. That would also be helpful. All right, so some basics here, going all the way back to algebra 1 here. Powers of 2. Okay, so what is 2 to the negative 2 power, and so on, all the way 2 to the 7th. And you should know these. And the better you know your powers of these numbers here, the better you're going to be at exponentials, and the better you're going to be at the logarithms, because every logarithm is an exponential in disguise. So let's get to it right here. So here we go. All right. 2 to the negative 2 power is 1 divided by 2 squared, all right, which is 1/4. All right, the negative exponent, when a term, a base has a negative exponent, it actually reciprocates the base, and the reciprocal of 2 is 1/2, and that's why we end up with fractions here. So 2 to the negative 1 power is 1 divided by 2 to the first, or 2. So it's simply equal to 1/2. And you can verify this on any T84 scientific calculator you like. That's not a problem. You can verify everything I say. 2 to the 0 power is defined to be 1. We have any number to the 0 power is defined to be 1 with exception of 0, so x cannot be equal to 0. So there's your 0 power rule. Okay, let's call that the 0 power rule. 0 power rule. Okay, any number to the 0 power is 1 with exception of 0. 0 to the 0 power is not 1. Okay, try it on your calculator. It will not give you 1. It's indeterminate. So moving on, here we go. 2 to the first is obviously 2. 2 squared is 4. 2 cubed is 8. Okay, you simply multiply by 2. It gets 2 times as big. All right, that's what powers of 2 are all about. 2 to the 4th is 16. 2 to the 5th is 32. Okay, once again, you just simply multiply by 2 every time it gets twice as big, and that's what powers of 2 are all about. Okay, 2 to the 6th is twice as big as 32, which happens to be 64, and 2 to the 7th is 128. Again, you multiply by 2. All right, it's powers of 2. All right, powers of 3 are the same idea here, but with base 3. This is base 3, powers of 3. And pretty much the same idea, but we're going to multiply by 3 in each case. Okay, so here we go. So this is 3 to the negative 2 is 1 over 3 squared, or 1/9. Right, 3 squared is 3 times 3, or 9. So you get 1 divided by 9, or 1/9. The next one, you have 1/3, and then 1, and then 3, 9, 27. Okay, obviously we're multiplying by 3 here, because we have powers of 3. Oops, excuse me. Let me go times 3 here. Okay, so times 3. Times 3. You just keep on multiplying by 3 in your head. 27 times 3, 81. Times 3, 243. All right, 3 times 80 is 240. 3 times 1 is 3, so you get 243. All right, those are called powers of 3. You keep multiplying by simply 3, right? All the way through. Now, powers of 4, similar idea. So here we go. So you have 1 over 4 squared, or 1/16, 1/4 here, and then 1. There's your 0 power rule all the way through. Any number to the 0 power is 1. There's your 0 power rule. Okay, 1 times 4 is 4, times 4, 16, times 4, 64, times 4, 256. Now, if you had me in the past, in Algebra 1 in years past, you should know all this, because I do this with all my 9th graders, and we get really good at exponentials. Okay, or if you were in my an 8th grader in my Algebra 1 class, then you saw this in 8th grade. Okay, but it's really important that you guys get good at your exponentials. And if this is the first time you practice something like this, well, guess what? You just learned something. All right, and here we go. 1 divided by 5 squared, or 1/25. It's 1/25. And then you get 1/5, and then 1, 0 power rule. 5 to 0 power is 1. And then you get 5, 25, 125, 625. Okay, again, you multiply it by 5 times 5 times 5 times 5. You can verify all of this with a calculator, okay? Not a problem. Oh, and the powers of 4, I forgot about that. So times 4, right? Times 4 times 4. I mean, you just keep on multiplying by 4 for powers of 4. Keep multiplying by 5 for powers of 5. And so on. And then powers of 6. So you have 1 over 6 squared, which is 1/36, and then 1/6, and then 1, 6/36, and 2/16. You can tell that I obviously have these memorized because, you know, the more familiar with the numbers, the better you get. I have a lot of practice, obviously, since I teach this stuff. But you too will get a lot of practice, okay? So you got to be good at your powers in exponentials to be good at logarithms, because every logarithm is an exponential, okay? So what we're going to do now is we're going to get into a little discussion on log properties, how they're used, but also their misconceptions, so you can see how to use them and how not to, okay? And this just comes from teaching this stuff over the years. I've seen people use them well and not well, so this is what I've seen. All right, so let's take something that we can deal with, okay? So something that we know. All right, so we know, okay, from our previous discussions what log base 10 of 100 is. Okay, we know what that is. Okay, we know it's 2 because when I've talked about this is base 10 now. This is the common log. Here, I talked about how you take the base, okay, the little number right here is called the base, and you think, okay, let's label that base. All right, you take the base and you ask yourself, you know, 10 to what power? Okay, this is what you're thinking here, okay? 10 to what power? Let me write a little bit better. 10 to what power gives you 100, okay? And the answer is obviously 2. 10 squared is 100. So x has to be 2, so this has to be equal to 2. So I'm going to write down a 2 here, okay? So log base 10 of 100, that's how you say it. Log base 10 of 100 is equal to 2. Now, let's talk about the property here. We know that log base 100 is equal to 2. We know, because 10 squared is 100. That's obvious. Now, this property here, I call product to sum. And the reason why I call it product to sum is because log base A of B times C is called a product. Okay, so this is a product right here. Okay, and then we switch it to a sum. Look at this. That's called a sum. So product to sum. Okay, look at that. There's a plus sign right there. So you split the log of a product to a sum of the logs. So I just simply call it product to sum because you're going to split every product, the log of a product that is, to a sum of 2 logs. Okay, so this is what I call product to sum property, property number 1. All right, so I'm going to apply it properly here, okay, and then I'm going to show you guys the common misconception that I see from all the way from Algebra 2 all the way up to Calculus, okay, because you start seeing logs in Algebra 2, you see them in Pre-Calc, and you see them in Calc. Okay, so here we go. Log base 10 of 100. Well, we know that 100 is 10 times 10. So I can rewrite this as log base 10 of 10 times 10. Okay, obviously 100 is 10 times 10. That's called the argument. 100 is simply 10 times 10. So I didn't do anything fancy there. So notice that I wrote it as a product. Okay, well, every product of logs can be rewritten as a sum of the 2 logs. So I can say, okay, this is equal to log base 10 of 10 times, I'm going to notice the multiplication symbol here, log base 10 of 10. Notice that I split the log into, excuse me, what did I just do? I just did the common misconception, because I'm thinking the conceptions here. So this is going to be equal to log base 10 of 10 plus, okay, the sum of the 2 logs, okay, log base 10 of 10. Okay, so let me just rewrite the numbers here. So I split the product into a sum of the 2 logs. Okay, this is how you use it properly, okay, and then I'll show you what happens. I wrote down times on accident because I was already thinking about the misconception. Okay, I got to be careful what I do here because, you know, I'm trying to teach how to use it properly and then incorrectly. Okay, so here we go. So what's log base 10 of 10? Well, it's got to be 1 because 10 to the first power is 10, all right? And then the next one, log base 10 of 10 is 1 because 10 to the first power is 10. I mean, 10 to what power gives you 10? Well, the answer has to be 1. And obviously 1 plus 1 is 2. And notice that these are the same, okay? Same. And they better be, all right? So whether you evaluate the log just by switching to an exponential, all right? Log base 10 of 100 is simply 2. We knew that in the very beginning. Or you apply the properties. You take the log of a product, switch it to a sum, or rewrite it as a sum of the two logs, all right, and then evaluate. You should get the same answer. We should get 2. All right, but watch what happens when you do it incorrectly. Okay, so this is the incorrect way. And I'm showing this to you because it's really, really helpful to learn how not to do it, okay? Learning what not to do is just as important to learn what to do. In fact, sometimes people think it's more important. Okay, so I'm going to take the same log base 10 of 100, all right? And then I'm going to rewrite it the same way I did before, log base 10 of 10 times 10, okay? Obviously, 10 times 10 is 100. All right, now some people think that a log of a product is just the product of the logs. So I'm going to write it as such, okay? I'm going to take the log base 10 of 10 times log base 10 of 10. So notice that whoops, sorry about that. I have a product, and then I write the log of a product as a product of the logs. This is incorrect now, okay? And you're going to see why here in a minute. We know the answer is 2. We just did it 2 different ways. Well, watch what happens. In the first log here, we get 1. The second log, okay, we get 1, and 1 times 1 is 1. And so, obviously, we don't get 2. We got 1. And this is incorrect. You can try this on a calculator. In fact, let's do it. On a T84, or Desmos, or whatever calculator you want to use, it has the common log on it. So let's evaluate it. So the log base 10 is called the common log. So you just enter log of 100, right? And then you hit enter. Now it doesn't show you the base 10, but everyone should know that the common log is base 10. So even though the calculator doesn't indicate that it's base 10, it's common knowledge. Okay, and notice that we get 2, right? It's not 1, it's 2. And then log base 10 of 10, as I said earlier, that should be 1. Right, and that's what I evaluated earlier, because 10 to the first power gives you 10, and that's why it's 1. Again, every log is an exponential. It's the value of the exponential. And that's what you guys got to learn, okay, is that, when we're evaluating logarithms, we're actually dealing with exponentials. Okay, property 2, a little bit different here. It deals with the quotient. Okay, so this is a quotient to a difference property. Let's take a look at it here, if I can get my program to work. Come on. Give me a second here. All right, now let's continue. Let's take a look at property 2. We call this quotient to difference property here. So we have what's called a quotient. B divided by C is typically called a quotient. Whenever you're dividing two things, it's called a quotient. And notice that we're going to switch it to a difference. Okay, so quotient to difference property. The previous one was called product to sum. This one's called quotient to difference, because you can actually split the log of a quotient to a difference of 2 logs. It's pretty cool. So I'm going to do it correctly here first, and then I'm going to show you what people do all the time, which is the common misconception, and we'll see how to do it correctly and how not to do it or deal with it. Okay, so here we go. Let's take something that we know. All right, so here we go. So we know that log, let's take base 3 example here. So log base 3 of 27/9. Okay, let's deal with something that we can deal with. So obviously 27 divided by 9 is 3. So this is equal to log base 3, all right, of 3. Now to evaluate this log in your head, you take the base, which is 3, and you ask yourself, this is what you think. This is the mental step. So mentally what you think 3 to what power gives you 3, okay? And the answer is obviously 1. So this is equal to 1 because 3 to the first power gives you 3. Remember, these are exponentials. I keep repeating that because you got to get that in your mind. So we know that this log of the quotient here, 27 divided by 9 is called a quotient, is equal to 1. We know that. But let me apply the property. So what I'm going to do is I'm going to take this quotient and I'm going to rewrite it as a difference of 2 logs. So this can be rewritten if you're going to use the property here. Log base 3 of 27 minus log, base 3 of 9. Notice that I switched from a quotient to a difference. Okay, quotient to difference. And let's evaluate that. So this one here, this is equal to, let me see, log base 3 of 27 has to be 3, because 3 cubed is 27. 3 cubed is 27. And that's why, by the way, I did all these exponentials earlier, because if I didn't review this, then a lot of you guys would probably be lost because you don't have these, memorized. But they're right here, guys. 3 to the third power is 27. And if you know all your exponentials, then this stuff's fairly straightforward. 3 cubed is 27, so log base 3 of 27 is 3, minus, let me see, log base 3 of 9. Well, 3 squared is 9, so this has to be 2. And then 3 minus 2 is obviously 1. And notice that no matter how you do it here, these are the same values. So initially, I just divided 27 by 9 and got 3, and evaluated log base 3 of 3 to get 1. And then I did it the second way. I rewrote it using the quotient to difference property. I rewrote it as a difference of 2 logs. When I say difference, I mean a minus sign, right? You need to understand the basic vocabulary of mathematics. Difference means you're subtracting 2 things. All right. And then I evaluated the individual logs and I got the same value. Now this is what people do a lot. And this is the incorrect way, okay? It's important that you guys see how not to do it. Okay, so I'm going to take the same expression. So log base 3 of 27 divided by 9. And people think that you can take a quotient here and rewrite it as a quotient of 2 logs. So log base 3 of 27 divided by log base 3 of 9. So the log of a quotient is a quotient of the logs. I see this a lot in all classes, from algebra 2 to pre-calc to calc. And this is how not to handle it, because if you simplify this, the numerator, log base 3 of 27 happens to be 3, and log base 3 of 9 happens to be 2, and you get 3 halves. And 3 halves is not equal to 1, obviously. Okay? And so this is incorrect. Okay? This is the incorrect way to deal with things. You can split a quotient into a difference, but not a quotient into a quotient. Okay? There we go. Now let's take a look at a few more properties here. Now, I accidentally wrote these out of order, so I need to go over property 3 first. This is the exponent property here, and it shows you how to deal with exponents of the argument. So I just call this the exponent property, because when you're evaluating log base a of b to the c power, c is the exponent, obviously. So I just refer to this as the exponent property, just because it kind of makes sense to me. Okay, and so notice here that log base a, again, this is the base, all right, and c is the exponent. You can shift that exponent to the lead coefficient. Notice that is equal to c times log base a of b. So you can shift that. So let me show you how it's used. I'll kind of play with it, and then I'll use it here up in property number 4. So let's say we have let's see. I'll show it two different ways. Okay, so one way is this. So if I have 2 times log base 2, let's say, base 4, excuse me. So base 4 of 2, okay, I want to work with this here. So notice I have a coefficient up front. I have 2 times the log base 4 of 2. So notice that if you start off with an exponent, you can shift it out to the coefficient, or you can go from right to left and take that coefficient and basically rewrite it as the exponent of your argument. So you can take this and shift it up here. Okay, so you could rewrite it as log, okay, base 4 of 2 squared. Notice that I shifted it up to the exponent of the argument. Okay, why would you want to do that? Well, if you evaluate that, you get log base 4 of 4, and that's simple, right? 4 to the first power is 4, so you just get 1. So that's going from coefficient to exponent, but you can also reverse the process and go from exponent to coefficient. So let's say that you're given this, log base 6, let's say, of 3 to the 6th power. Okay, now 3 to the 6th power is huge. Most people can't evaluate that in their head, because if you multiply 6 3's together in your head, you're going to be in the quadruple digits, okay? And so most people can't handle that in their head. So what you do is you shift this to the coefficient. Again, this is your exponent, and you shift it to the coefficient. All right, it's a log property. You can validate these all with the calculator if you like. Okay, so this would be equal to log, 6 times the log, base 6 of 3. Okay, why did I go base, oh, I didn't mean, I'm sorry. Didn't want base 6, I'm sorry. I wanted base 3, so rewrite this, sorry about that. So, one more time here, so that was a little bit difficult to evaluate just a minute ago if I didn't change that. So take a moment and change the base from 6 to 3. I apologize. So we're going to shift that exponent to the coefficient, and now you have 6 times the log of base 3 of 3. Well, this portion right here, that's just 1. Right? 3 to the first power is 3. It's always take the base to some power. 3 to what power gives you 3? And the answer better be 1 in this case, because 3 to the first power gives you 3. All right, and then you get 6 times 1, and that's obviously 6. So moving the exponent to the coefficient, or from coefficient to exponent, that helps you out in some cases. So it's used both ways, and depending on what you're dealing with. So you got to get familiar with both examples here, shifting from coefficient to exponent in the first example, and then shifting from exponent to coefficient, all right, in the second example. All right, now property 4 deals with property 3. Notice that we're dealing with log base a of a to the c power, and it states that it's equal to c, but why is that? All right, so let's take something we know. Okay, so we have log, let's say base a of a to the c power. Again, we're going to take this exponent here and shift it to the coefficient, shift or rewrite, one of the two, and then you have c times log base a of a. Well, if you just think about this log here for a second, you think, okay, a to the what power gives you a? And the answer has to be 1, just like it was earlier over here, but instead of a base being a numerical number, all right, it is just a variable. Like, a to what power gives you a? And then the result has to be 1. So really this is just c times 1, or simply c. So whenever the base of the log is the same as the base, you're going to get that exponent. So for example, if I had something like this, log base 7 of 7 to the, 5th power, okay, is simply 5. So whenever the bases are the same, you simply get the exponent. That's the use of it. One more time. So let's suppose you have log base 9 of 9 to the 5th. Okay, let me pick a different number. 9 to the 8th. Okay, that's going to be simply 8. All right. So whenever the bases are the same, the base of the log and also the base of the argument, well, you're just going to get that exponent. And again, this is just takes a little practice here, guys, and you will get a lot of practice in the activity and through all the work that we're going to be going through. So if you don't, obviously have it memorized initially, don't worry about it, because, it takes experience, it takes practice. Okay, now, sometimes it's important to switch the base and the argument, okay, switching a and b. And you do that, the log base a of b is equivalent to or equal to the reciprocal, basically, or 1 divided by log base b of a. Notice that they're switched, okay? You're switching a and b, and you'll see that being used. So let me show you a little application here of it. So let's suppose that we're giving you this right here. So let me just make up some numbers here. So log base 32 now of 2. Okay. So this might be kind of tough for some people to deal with mentally. I mean, to do this mentally, you have to think, 32 to what power gives you 2? What would that be? And this is the mental step. So mentally, you're going to be, thinking about this. But for a lot of people, this is hard. 32 to what power gives you 2? I mean, because it's not a whole number. It's a fraction. So that's tough for some people. So what's easier for some people, or most people, trust me, I deal with a lot of students, right? And so I'm saying for most people, switching the base in the argument is a lot better. Okay, so remember, this is the base, and this is called the argument. So switching the two, you can rewrite this as 1 divided by log base 2 of 32. And this, my friends, is a whole lot easier to deal with. Okay, so if I rewrote this, if I was going to evaluate the denominator here, log base 2 of 32, you'd have to do this. 2 to what power gives you 32? Now this is something that people can handle. Okay, and again, this is the mental step. 2 to what power gives you 32? And guess what? We did that earlier. We did up here. And guess what? 2 to the 5th power gives you 32. So if you know your exponentials, all right, it can help you evaluate your logs. So we know that this is just 5. All right, 2 to the 5th power is 32. So really, this is just 1/5, and you're done. Okay, like I said earlier, this is a fraction, not a whole number. Because 32 to a whole number gives you a huge number. Like 32 squared is 32 times 32, so the answer can't be a whole number. It's got to be a fraction. Okay? Let me show you one more time. Let me give you some more experience here. Let's suppose we have log base 7 of 3. What is this equal to? And again, this is hard for some people because you have to think, 27 to what power, gives you 3. And that's, what is x equal to? And again, that might be tough. So what you do is you rewrite it. 1 divided by log base 3 of 27. And this is a whole lot easier. So instead of thinking 27 to a power, you think 3 to what power is 27. And this, my friends, is easy for most people. All right, if you just go back up to the beginning here, you look at your powers of 3. 3 cubed is 27. See? So switching the base and the argument can be really beneficial. All right, and so we know that 3 to the 3rd power is 27, so we get 1/3 because that's in the denominator. Okay, so this property here, 5, really comes in handy when you're evaluating logs, obviously, without a calculator, which is what we're going to be doing in the activity coming up. All right, you're going to use the one between your ears, guys. This one. All right, the one between your ears, not the T84, not Desmos, not all that. Okay, so here we go. Next one. Next property here. Property 6. So property 6 is called the change of base. Now on a T84, there's only 2 bases. When you see the log button right here, that's base 10. That's called the common log. When you see ln, natural log, that's base E. But on the T84, there's no other base. So you can't evaluate log base 2 of 5 on the T84. You have to know what's called the change of base formula. All right, so this one's important. When you want to evaluate a log, let's say that you can't do mentally for some reason, and you need to use a calculator. Well, if you're in base 2 and the calculator only has base E and base 10, well, then you better know this because this is the only way to do it. All right, so if you have, let's say, log base 64 of, let's say, 16, and you want to figure out this right here, there's a couple different ways to do it. One way is to use, and again, this is without a calculator, of course. All right, you could change the base to any number you want. Now, 16 and 64 are base 2 numbers. So if they're both base 2 numbers, it might be wise to change to base 2. Okay, now if you do that, you do it like this. Log base 2, look at that, of 16 divided by log base 2 of 64. And notice what I did, okay? The argument goes up top, and then the old base goes down below. Color coding, here we go. So notice that I picked base 2. I'll pick base 4. I'll do it differently, and I'll get the same result using another base. But doing it this way is doable because I know that 2 to the 4th power is 16, so this is 4. I know that 2 to the, let me see, 2, 4, 8, 16, 32, 64. 1, 2, 3, 4, 5, 6. This is 2 to the 6th power, so this is 6. All right, 2 to the 4th power is 16. This is powers of 2. See, notice that I just busted out powers of 2. I wrote them down so you can see my thinking. All right, and 6/4 is 2/3. And so my answer is 2/3. Now, is that the only way to do it? No. Okay, I could take log base 64 of 16 and you change to base 4 because these are base 4 numbers as well. Okay, now if I change to base 4, because I said you can change to any base you want, you get log, all right, base 4 now of 16 divided by log base 4 of 64. And what does that equal? Well, log base 4 of 16 is 2, because 4 squared is 16, and log base 4 of 64 is 3. Aha! Why? Well, because, 4 squared is 16, and 4 to the 3rd is 64. It's all in the beginning. This is why I started off with this right up here, guys, because 4 cubed is 64, and 4 squared is 16. These are powers of 4, base 4. So if you know your powers really well, then you're going to do well with logs. If you're not good with arithmetic and you don't know your powers, this is going to be extremely difficult. So I encourage you guys to really trust me here and get down to your basic arithmetic and your powers. Let me give you another example. Log base 125 of 25. Now, this is tough for some people too, because you got to be thinking, 125 to what power gives you 25? I mean, what's x equal to here? I mean, most people can't figure that out. Unless you're trained really well, okay? In the past, I'm talking about. So what you do is you change it to whatever base you want. In this case, these numbers are base 5. All right, so let's change to base 5. So log base 5 of 25 divided by log base 5 of 125. Once again, 25 goes up top in the top argument. The base goes into the argument of the denominator, okay? Since 5 squared is 25, the numerator is 2. Because 5 to the 2nd power gives you 25, and 5 cubed gives you 125, so this is 2/3 as well. Okay? And you can check that with a calculator too. But you'll have to use your change of base rule, guys, because base 125 is not available on the T84. I don't even know if Desmos can do it. I have to check it out. All right, so that's how they are used. All right? And in 3E2, you're going to be using all of these. Okay? So in 3E2, you got the product to sum property here. So product to sum. And then the next one, you got the quotient to difference. There's a minus sign here. Okay, and then you've got this the exponent property. This is what I refer to as the exponent property or exponent rule, whatever. Okay, and here, switching the base and the argument. Switch base and argument. Let me see, this one's a change of base rule. And this one here is pretty evident. A to the first power is A. A to the first power is A. That's obvious. And then here, when the bases are the same, you get the exponent. So this one here uses the exponent rule. So these two are similar here. So you got all these properties here, guys, and what you want to do is figure out what all of these are equal to in terms of A and B. All right, so given that log base 3 of 8 is A, okay, given that log base 3 of 8 is A, and also given, log base 2 of 3 is B, okay, how can you represent the following numbers, all right, in terms of A and B? So I'm not asking you to figure out a numerical value. I'm actually asking you to evaluate them or simplify them by using the properties, but simplify them in terms of A and B. So the question is, how do you do that? Okay, how do you do that? So let me give you, give you some time on that, actually. So let's see. So I'll tell you what, when we are in class live, I will show you this. We'll do this together right here. And then in small groups or breakout groups, because we're online this year in 2020, all right, we'll do this in breakout groups, and then I'll work with you here. This is challenging, but it's going to be fun. When we did this in class in the prior years in MRWC, in the beginning it was a little abstract because you're not going to get numerical values, and that's what throws people a curve. You're going to rewrite these expressions in terms of A and B by using the properties. So it really, really forces you guys to understand the properties. And it's a little bit different than what you've done in Algebra 1 and 2, actually Algebra 2, and also a traditional pre-calc class, because typically they ask you to figure out the numerical value. Well, these don't have a numerical value. Your answers are in terms of A and B. All right, so when I see you next, all right, I will discuss how I'll exemplify, and I'll practice with you here, and I'll show you a few things, and then we'll do the activity here 3E2 in groups. Okay. All right. With this is Mr. Ainsworth here, and once again we are in section 3E2 here on log properties and how to use them, and in all kinds of variety of ways. All right, and I'll see you in my next lesson here later on. Take care. Bye bye.